to work your way down, you can just work your way through the table and just pick cars out from the ladies and please.
I think it does, I needed two, but I've only got one head.
I have never worn a hairnet. What is it for walking?
Wear that and then you have that.
Yeah, like
Out. So we really are very much at the early parts of the excavation work. So everyone probably wonders so when we still get this side, first thing we have to do is write those things. That takes quite a long time. But we can once that's done, we have to build the what we call the fire wall.
don't worry, I'm it. Sorry? Yeah, my mom and my sister's coming.
It goes approximately 30 metres from the top of that wall to the bottom. About 15 metres. So within those walls, there's a lot of steel. So just explaining how we did that. We actually did a deep 6.3 metres wide, 30 metres deep in one go. Now, if you normally do that, you'd expect all the ground to collapse in and not stay stable, right, when you dig a big hole like that in the ground. So, as we dig that hole, we replace the excavated material with a fluid, and that fluid is quite similar to water, but a bit thicker, and we call it bentonite. And that, we fill the trench with that as we excavate, and that keeps the side walls stable. Okay, so they don't collapse, the trench doesn't collapse in as it's excavated. And we excavate it in two ways. The top sort of 15 metres, the top half of that wall, is generally all sort of soft clay material. So if you look behind you on that excavation profile, you see just where behind the excavators, there's like a black band of material at the bottom, and then above it, there's a whole lot of red looking material. All that red stuff is a silty, sandy clay. And we can take that out with a grab. So when we dig the trench, we do that with like a clamshell grab, and we take that out, drop it away at the top, and we get rid of it. The rock's a bit different, that's a bit harder. So we use a machine called a hydrophase cutter to get through the rock. And that's basically a big 2.8 metre wide frame with two massive rotating grinding wheels on the bottom of it. They're probably about this big in terms of diameter. And they will chew away at about 50 millimetres of rock per minute. And it takes about, in total, between 3 and 4 days to excavate a full panel. Most of that, getting the rock out. We get the soft out quite quickly, a matter of hours, but the rock takes days to get out of the trench. And the reason we're going so deep into the rock is double-fold. One, it's providing permanent walls for this station box as we excavate to the bottom. But the other reason it goes so deep is because the diaphragm wall is going to be used to support any future structures that are built on top of this station in the future. So hence why it's a metre thick and very, very heavily reinforced. So, once we dig the trench for that panel, you've got a hole in the ground that's basically full of fluid. Into that, we drop steel cages, reinforcing cages. Very heavy, talking like sort of 70 tons of steel goes into each of those panels. So we prefabricate the reinforcement cages off-site in steel. We bring them to site, we lift them up vertical, which is pretty impressive when you see them lifted up vertical, and we drop them into the bentonite fluid down to the bottom of the hole. Once that's done, and very quickly, because we don't like to leave it like that for too long, we need to displace that bentonite fluid with concrete. So this works a bit like when you get oil and water in a glass. We put concrete all the way down to the bottom of the hole using pipes. We drop it down the pipes to the very, very, very bottom. Let the concrete spill out, and it self-levels itself. It needs no agitation and no shaking. And as the concrete goes in, it pushes the bentonite up. And we pump the bentonite off the top of the trench and send it back to our plant for reuse. So it's like oil and water. The bentonite sits on top like oil, concrete displaces it underneath, a bit like we pour water into oil. Okay. Once it gets to the top, we've got our panel finished. We just need to make sure we've got all the bentonite out of the trench. Those bentonite pockets in the concrete are bad. Okay, that means we get, as I excavate, we'd end up with soft spots in the wall, all of which will cause leakage and quality problems later. So it's very, very tricky actually to keep them separated. I've just made it sound really easy. Promise you it wasn't that easy. So with the D-wall built, we can start excavating. So we excavate to the underside of each of these steel frames that you can see in here at the moment, and then we would install the steel frame. Once that steel frame's in, we dig down to the bottom of the next steel frame and we put the steel frame in. And this phase we're in now is excavating down to the next steel frame, and again we'll put another steel frame in. There are 3 in total, so you can see 2 now above you. There's 1 more to go in before we reach the bottom of the station box. And in total, there's about 2,500 tons of steel to go in this excavation to support it. Now, the diaphragm wall is permanent and will form the permanent walls of the future metro station, but the steel is temporary. So in the future, the next contractor that comes in will use, you see all these sort of blue circles that are in the wall all the way around. These are couplers for the reinforcement. So all that steel reinforcement we put in concrete, we'll screw that into those, where all those little blue holes are, to form the new concrete slabs, which basically do the same job as the steel work in supporting the walls. And then we can take the steel out once that's done. So we do permanent walls, temporary steel. Somebody else does permanent slabs, temporary steel gets removed. Okay. In very, very simple terms. Okay, tunnels, a little bit different. So we're not quite deep enough yet to where the tunnel boring machines will come through. So these are the machines that are physically building the tunnels. They will come through this eastern end wall from Clyde, some parts early next year. And below the level we're currently at, like I say, we've got another 13, 14 metres to go yet before we reach the bottom. Those are 6 metre, just over 6 metre diameter. And they literally form the tunnel as they go. So they're like a bit of a worm through the ground. They excavate and they push out completed tunnel rings behind them as we go. They're currently on their way to Sydney Olympic Park. There's 2 on this job called Dorothy and Betty. Yes, that's right. I'll get it right on here. Yeah. Yeah. My other engineers are sneaking in on these groups. They're on their way to Sydney Olympic Park. They'll get removed at Sydney Olympic Park and taken back to Clyde near the racecourse, where they'll be put back in the ground, and then they will tunnel their way to Parramatta. Like I said, hopefully arriving here early next year, but it is tunneling.
Quick question.
Yeah, go on.
So these things here, what do they, like these things, what do they mean?
You'll say you've got a young engineer with us. Right. So they are the dates we built them. So they're the dates we excavated, put steel in, and poured the concrete.
Alright, that's pretty cool.
Yeah, so that's actually our tracker board that used to live behind my desk until about a week ago when we finished. So we do keep track on what's going on. There's obviously a lot more paperwork, we're building these things and that, but that's our tracker so we know where we're going and how we're doing it. Tunnel machines come through, push through the Parramatta station box. So the plan is to hopefully excavate most of the station box before those machines arrive. on, young
How
man.
long probably will it take to build so far? Like the tracks and everything?
Oh, a long time. Now, to excavate all of this box through to its bottom level is probably the end of next year.
Oh, okay.
Yep, okay. But it'll be a long time after that before you see tracks, I think.
Yeah.
I couldn't give you an exact time, but it'll be a while. So
Yeah.
nobody's actually yet been given the contracts to do those works yet. So Sydney Metro are working on that at the moment.
Okay.
But yeah, to dig it, it's quite a slow process, unfortunately. Now, the reason it takes quite a bit of time is we need to be extremely careful. We're right in the middle of Parramatta, where we've got a lot of sensitive structures and buildings around us. We're extremely close to some of the high-rise office blocks here at 25 Smith Street. We're 1.5 metres away from the heritage-listed Roxy Theatre. And right at the other end near Church Street, we're only 1 metre away from 218 Church Street, which has the shops at the bottom and the Pilates studios on top. So we're very, very, very close. And hence why these structures are all so big, is to make sure none of these walls move or deflect more than they're allowed to. So none of these structures at the surface are affected by the works that we're doing. And we have to monitor that all the time. So we're not guessing, I can assure you. There are instruments that live within the concrete that tell us exactly how much these structures are moving to fractions of a millimetre. So we know exactly what's going on all the time. So tunnels push through Parramatta station box, and then they'll push out the other end of the box and they'll head off to Westmead, which is about another kilometre, and they terminate at Westmead. So part of the Western Tunnelling package, which is the bit Camino Langaroca doing, is from Sydney Olympic Park to Westmead. There are other contractors doing the central part of Metro West and another contractor doing the very eastern part of Metro West. After us, there'll be station FRP contractors, concrete contractors will come in and build concrete slabs and walls, and then fit out contractors will come in and put your escalators and finishes and tiles and electrics and plumbing and all the other things that need to go in.
So pretty much, since the boring tunnels are going to be here, you say like next year, sometime. How long does it like? Is it automatic or is there someone controlling it? Sorry.
No, that's all right. So the tunnel, that's a good question. So the tunnel machines normally are manually driven. However, the two machines that we have are the first ones in Australia that are actually autonomous. So the computer software actually drives the machines, God help us all, right? But the computer software drives the machines.
Oh, that's actually pretty cool.
Yeah. One minute.
Yeah, will it be like light rail services connected to like the metro station, like a stop?
Not directly, but just outside the site at the top, you've probably seen the metro station, yeah?
Yeah.
On the way to Parramatta Square. So they're doing the testing at the minute. I can't tell you, I don't know exactly when they're going to finish, but hopefully soon. And then the light rail will be open. But there'll be no like tunnels or anything like that or bridges as far as I'm aware. It'll just be you'll exit the station from here at the surface and walk across to the light rail stations.
So how long are you guys being contracted to use station?
We do the dig, so we build the tunnels, we do the excavation of the boxes, and that's us done. We walk away from it then and we give it to the next people. You two are on it. Are you my future recruits for engineers? I'll give you 1 minute. I'll let this lady ask first and I'll come straight back to you.
What kind of rock is it?
This is all sandstone. So it's not like the really pretty sandstone that you get that would form your copings or cappings for your walls at home, for your gardens or anything. It's very grey, pretty ugly looking sandstone really. But it's pretty... Yes, you'll get some slight variation as you work your way through because we get slightly different strata and dikes and fault lines through the rock. But typically it's all a very layered and grey rock is the sandstone in Parramatta. It's not like the nice red and sort of light coloured sandstone you get in some places. That may be down more towards Sydney CBD. So yeah, so the other black stuff you see in there is siltstone, which is really a compressed clay. To be honest, that's gone black. And that's a bit like shale, a bit like slate. It fractures a bit like slate, but it's actually quite easy to dig through still. So we can get through that with the excavators with just the buckets on before we start putting the hydraulic hammers on the machines. But the sandstone here is pretty much like as hard as concrete. It's, you know, pretty hard. Go on, young man.
Will it cost a lot of money to do this?
Oh, now you're asking me questions I have to be careful about answering. Yes. Yes is the answer.
How many people are you thinking that are going to like use this metro system?
Oh, you really are asking good questions. I couldn't tell you. I don't know. I'm sure if you go up and ask my metro counterparts upstairs the same question, hopefully they'll give you an answer.
Will there be a lot of platforms, like, or just two for? Just
Two platforms, yeah. There's one train runs each direction in the metro system. Yeah.
Island arrangement or side arrangement?
In this one island arrangement. They are future engineers, right?
No, it's a hobby.
Oh, really?
How deep are we in relation to the river?
You are, I would say 10 to 12 metres below river level. Yeah, 100%, yeah.
Is this
Yeah.
thing
So
like?
is the match leaky?
So I'll actually show, when we do go back up, I'll show you the joints at the top of the diaphragm wall from the top. I left a couple exposed because usually you can't see them very well, but actually because we've wire sawed the top of the D wall off like a cheese wire basically, you can really see the joints really well, which is unusual. So I've got a couple of those which will answer that question for you. But in terms of leakage, you can see the joints that go around the D wall, you see these little vertical lines. There's very little water coming up at the minute, and the water table sits probably around where that second frame is. That's, so we are well below it now, below the natural water table, and there's the odd bit of water you see coming through the joints, but it's actually not bad. It's better than I had expected, to be honest.
I've got two
In
questions.
the
One,
past, stuff you've seen on TV, they've had a lot of problems.
Oh, if you get it wrong, it can be bad, and I've seen it happen. So, all good. Go on, young man.
so one, is that like the layout?
It is. That's the engineering layout. Yes.
And two, will there be a metro open day, another one, when this station opens?
I'm sure there will be. I won't be here for that one, but I'm sure somebody will do one.
Oh, okay. When you
Yep. Yep. Go on, mate.
When you start digging, do you know what's underneath? Whether you're not going to hit any utilities or any pipes?
Yes.
Or anything that's underneath?
We do a lot of work in terms. We actually GPR the whole site, so we take the utility drawings which we get, which are sometimes quite questionable and a bit vague. So what we do is we do what's called a GPR scan, which is ground penetrating radar. So we scan the whole site, and that finds anything that we've not seen or it doesn't appear on the utility drawings. We then will do like actual physical finding those services. So you might have seen around town there are a truck with like a vacuum line on them. So you get like what we call a wet vac. And what it does, it basically you hose down the ground with the water under pressure, and it sucks that material back up into the truck, so that you're not physically digging into the ground where you might actually cut a cable or something, which would be bad, right? So we actually remove the material from around any obstructions until we physically find them, so we know exactly where they are. We call that positive identification. So anything we think we're going to be excavating within, say, 2 meters of, we have to positively find it through non-destructive methods before we actually start excavating anywhere near it, because otherwise you're running a risk. Yeah. But yes, all the services through here have been cleared, I can assure you. Yeah.
When will the track finish? Like, where's the finishing location of the track?
At Westmead.
Oh.
Yeah, that'll be at Westmead for now. We're going to go up in a second, and then you can take it off again. Is it heavy? You can be first up the stairs then. I think we've got to. I think we're being ushered into making a move back up.
This doesn't even feel that heavy now.
Yeah. I've got to clear out so we can get the next group. But as we stand along the railings on here, if there's any more questions, I'll answer them. No problem. Okay. Right, who's ready for the 2 flights back up?
Oh, let's go.
그래.
You just take like
Very dead. Maybe.
You made it.
Has it been for your
Don't walk on that. Don't walk on this.
Mommy. Yeah. Hot drink back.
Answer that.
No. Yeah.
And I don't know if you got your iPad.
I turned it off.
No.
What are you doing? Oh, it's filming it. I'm going to use banana on your place, and I'm not going to come off. Yes, you don't have to.
Kira?
Change it.
Hold my hand, I want you to get up.
Anyone who's part of the archaeology and also the people back here, what is going on? No, this is very temporary. the permanent D-walls, diaphragm walls stopped there. This is all temporary. And this is our crane pads basically, which is specially designed for that big white crane there. Nope. Good. It is something to do with plants, I'll give you that clue, but that's not the answer. Yeah, so those that didn't see the joints in the wall, or it's not that, it's this one here. So this is the joints in the panels. And you see it's really hard to see. They hide actually really well unless you actually jet wash the top of the wall off. The joints on the wall actually come through like that. And that is to stop the water from migrating through. And the little yellow line that's through the middle there is the water bar, and that's a rubber hydrophilic seal. So what that means is if the water makes its way through this side of the joint and hits the yellow rubber actually expands in contact with water, which is what makes it hydrophilic. And that stops any water from passing through to the other side, the internal side of the station box. And as you can see, it works mostly. Sometimes it doesn't work, and that's where we get little leaks coming through the diaphragm wall that we need to repair. Oh, wait, I'll point it out. Okay, so anyone that's interested, that's the joints there in the diaphragm wall. So you can just see that sort of line.
I don't know how you're gonna go past it.
Wow.
Whoa.
That is why.
Oh, it's cool, isn't it?
You know that's this.
The stair that go up there. Oh my goodness. This headache here, right?
Hello and good afternoon, everyone. Is that working, Andre? No.
Yeah, it works.
I can just shout. So, it's really a bit sunny, so if you would like to come in under here, you can. So, hello? Hello. There we go. Okay, welcome to this is the heritage part of your tour, and my name's Amanda. We have Sam and Costa, and we're all archaeologists. We're 3 of the 50 odd people who are archaeologists, specialists, and also representatives who have been working on the site since 2022. So we started here when they were demolishing the buildings. I'll just turn that down a bit. We started here when they were demolishing the buildings, and we were carrying out archaeological investigation while demolition was going on. Then when the demolition had finished, we moved into other parts of the site, and we were carrying out our archaeological excavation while the building process was happening, while they were building that diaphragm wall, while they were piling all the around for the station box, and while they were digging out. So we were working at the same time as all the construction activities. So we would have a section of space, and we would, and quite a large section, I have to say, from here to the road down to there as one chunk, etc. And so we would be working alongside the civil contractors, which means that it was a really well organised structure. It meant that nobody was ever held up by anybody else. We were always there on the ground when all of the construction and demolition was happening. So we've been here for over 2 years, well, 22 years, I suppose a year and a half. But we have 2 sections left to excavate. That's a section on George Street and one over where the site huts are, where you came in. So we've got about 40% of the site still to go. So it's a very long process. But archaeology, the way we do this is we try and do it as fast as we can and as well as we can. The key thing about archaeology is it is destruction. When we have excavated something, we remove it. And so we have to make sure we have the best methods of recording. And we use really sophisticated digital methods, we use survey, we use a lot of photography, we have 3D reconstructions, and recording is absolutely the most important thing. Because once it's gone, it's gone. Because all we're left with then are the artifacts and the records that we've made. So when we come here, the way it works is we come onto a site and we've had an area of demolition, and then we're on a concrete platform like this, and we need the help of the civil contractors to get that concrete up. So we use big machines. We use a 20-ton excavator to remove all the concrete. Then we go down a scale and we go to a 14-ton excavator, and we use that to start bulking out the fields. So in Parramatta, because up until the 1980s, very few underground car parks were in existence, everything is just built up and up and up and up. So throughout the centuries and years, if somebody has a cottage, the next person will demolish it and then build on top. And on top and on top and on top. And this is how you get archaeological layers or stratigraphy. And here we've got 5 architectural phases. So it is very hot, so if you do want to come in here, please do. I don't want sunstroke or anything like that. Or we could hope for cloud cover. So anyway, the way the archaeology works is we work with big machines to start with, slowly getting smaller and smaller. The smallest machine we generally use is a 5-ton excavator, and it can do really delicate and precise excavation. And this is something we absolutely need to work with the civil contractors, and we have genius operators who can shave 5 centimetres off something or 2 centimetres off something, and we need that because otherwise it would take forever. So we rely heavily on machinery, but you can imagine it goes big machine, medium machine, small machine, then we get down to us. And so we're using a variety of tools as well. We have the big tools, which are picks and mattocks and shovels and hoes, and then the next scale down, as you get sort of to your finer and finer excavation, you start to move down to trowels and brushes and small tools. And if you've got something incredibly delicate, you may even go down to dental tools. So you've got a whole range from a 20-ton machine down to a dental pick, or yes, toothpick. So that's the way our archaeology works. What we've got here is archaeology spanning from thousands of years ago, which is the Aboriginal First Nations archaeology, and all the way through to the 20th century. On Church Street we had Aboriginal archaeology, then we had, on top of that, we had convict archaeology. And on this site we are very lucky because we've got the opportunity to expose 5 convict period huts. We've actually exposed 2 already, one on Church Street and one on George Street, and we've got the opportunity in our next phase of work to do 2 more on George Street. So when the convicts were here,